Welcome to another unit of the ISM course in Statistics 2. This time with a unit on the so-called goodness of fit test. This is one of the three tests which uses the chi-square statistic as test statistic, which we're going to discuss in the course of this, well, let's call this course or lecture. Well, with the goodness of fit test, what I'm doing is usually I have a data set, different classes, different groups, and I have absolute frequencies for them. So for example, I calculated data, which I later then grouped or classified. And then I want to test whether these groups or classes follow a certain given distribution. So usually I have two things, one set of absolute frequencies and one distribution. And my goal is, does my data set follow the given distribution? Well, so much for what I aim to do. What I'm doing, practically speaking, is similar to all the other chi-square tests. I'm using my distribution to get expected values which reflect how the data set should look like if it follows this given distribution, and then I compare this with my actual data. Well, practically it looks as follows. So here, first have my frequency table, so more or less different characteristics or classes, absolute frequencies, and my given distribution. If I have this, then I can start with my hypothesis, which just says H0, X does have the given distribution, does share this given distribution, and H1, the alternative, X does not share the given distribution. Okay, and how do I test this? Well, first by getting this test statistic. This again looks relatively complicated, but it isn't. So what I'm basically doing is first I'm using my distribution, the probabilities in the distribution, to get expected values. So I'm just summing up all the observations, getting my total number of observations, and then for each category, for each group, I'm multiplying the overall number of observations with my probabilities, with the percentage share in the given distribution. That's the n times p. That's here, this part, and this part, and that's actually, as I see here in the comparison, my expected values. So my expected values is just overall number of observations times share of this, or share in the corresponding distribution. Okay, so if I have these, I can just do the standard chi-squared calculation, actual value minus expected value, all of this squared, divided by expected value. That's the same as with all other chi-squared tests, which I could run here. If I have this, I'm only needing a reference statistic. The reference statistic here, I get as chi-squared, I minus 1, 1 minus alpha. The I here is the number of categories. So if I take a look here, on the left side, in the different rows, I have my degrees of freedom, so that's more or less the I minus 1. And the different columns, that's the 1 minus alpha. So if I, for example, here in this case, look for 4 categories, giving me 4 minus 1, 3 degrees of freedom. I look in the row for the 3, so the third row. Then I have an alpha of 5%, leading to me look in the column for 0.95. So this would result in a reference statistic of 7.8147. And well, that's test statistic and reference statistic. So my decision simply is compare both of them. And again, as with all tests, if the test statistic is smaller than the reference statistic, I retain H0. If it's larger, I reject H0. Okay, so much for the goodness of fit test. Let's have a look how this looks in an example. So for example, we have here Your CEO shares the opinion that all of your 3 products are demanded in approximately the same quantities. To test his hypothesis, you collect the data for 300 customers. That's then our data table. We have here the sold products for each of the 3 products, P1, P2, and P3. Our task, test for an acceptable margin of error, so for an alpha of 5% if the hypothesis can be retained. Okay, how we're going to go about this? Well, first we extend this table. So we take our table as is and extend this first by an additional column for our expected relative frequencies. So that's actually our distribution. Here it says same share for each product. So this means each product has a relative frequency of 1/3. So I expect a relative frequency of 1/3 for each product. And well, I have in total 300 products which are sold. So meaning the 1/3 per product translates into expected absolute frequencies of 300 times 1/3 for each of the products. So for 100 each. So in the end, the sum for the absolute frequencies, the actual absolute frequencies, and the sum of the expected absolute frequencies should be the same. Okay, could be small changes due to rounding errors, but it should basically be the same if you work exactly. Okay, so we have the absolute frequencies, the expected absolute frequencies, so we can just use those numbers in our formula for the chi-squared. So we go here, 86 minus 100 in parentheses squared divided by the expected value 100. That was product 1. Then we go product 2, 111 minus 100 parentheses squared divided by 100. That's product 2 plus 103 minus 100 in parentheses squared divided by 100. That's product 3. And we only have these 3 products, so that's all there is. And this leads to a test statistic of 3.26. This one we will just copy in the next slide. So here we had this test statistic, chi-square empiric, 3.26. And then next step we need a reference statistic. This is here, chi-squared, I minus 1, 1 minus alpha. Alpha was 5%. Well, we have 3 categories, so I is 3. So we get 2 degrees of freedom and for the other value 0.95. So we take our table, take a look, row 2 and column 0.95, leading here to a reference statistic of 5.9915. This in general is here a value. Then we just compare these 2 values, the test statistic and the reference statistic. So our decision is basically here, our test statistic, which is smaller than the reference statistic, leading to retain our H0. So retain the hypothesis that all 3 products are demanded in approximately equal shares. And well, that's more or less what the CEO suspected from the beginning. So his hypothesis is actually to be retained. Okay, and this was then all there is to this short example, this short unit on the goodness of fit test. And well, I hope you enjoyed listening to it. And if you're looking for additional exercises, additional units, feel free to visit the rest of the course or take a look at the corresponding playlist. I say goodbye and see you next time.